Okay, welcome back. This is another video about Excel functions that are often used when I give a course that combines Excel with machine learning and neural network algorithms. So in this, we're going to talk a little bit about the let function. Let function allows you to name variables and use formulas all within an in-cell formula. So it's really nice to be able to do that within a cell without calling some background programming language or anything. So I'll show you a little bit of what that's like here. So again, we're going to use this, a few good things to know about Excel, this Excel file that I created, and we're going to explore the tab that talks about the let function. Okay, so here again, down at the bottom, I've magnified just the formula bar. I've expanded it because some of these formulas within the cell get a little lengthier, and it'll allow us to see the entire formula. So as we start up at the top, we're going to look at this let function. This goes back to the initial Excel tabs where we talked about variables. Here we just have x1 and x2, so two inputs. We have x naught, which we set to 1. Here's the different theta parameters, so theta naught, theta 1, theta 2. And we're going to just do a simple matrix multiplication function. So I'm going to actually go to the cell where I explain this and copy this entire formula. I'm going to go to this y value here and paste it. And so let me just check. Yep, it's showing everything. So we have here's how the let function works. First you name the variable. So theta right here is named. And then you can prescribe, like if it's a single cell or if it's multiple cells for that. X is going to be our next variable. As you can see here, it's B10 through D10, so it's highlighted here down in red down below. Y is going to be another variable that we're defining. And that's going to be the matrix multiplication, so M mult of x comma theta. And then the last one here, is going to be your output. So you can have multiple different variables that you define, some of them referring to cells within Excel, some of them referring to variables within the let function that you have already defined, as we kind of showed here in this y variable. And then after you've defined everything, you can output any one of those variables. So this could easily be theta, and I could output the theta values. I could output the x values. But in this case, we're just going to output a y value, which is the matrix multiplication of everything. So we press enter. And you can kind of see here on the Excel sheet that it returned this y value. Oops. So I'm now going to go ahead and copy that again. What if your output is more than a single value? What if it's a vector or a matrix? I can copy this whole formula again. Maybe this time we want to return x. So I just changed that last value there. I'll highlight it so you can see that to x. And now it's going to reach back and gather the x variable, which we've defined as these values up here. And it returns that as a dynamic array. So that's pretty cool and just a very simple example of how the let function works. Now let's actually go down to something a little more complex. So I'll try to Okay, this shows a little bit of it. Let me make sure if that's all on screen. Not quite. Um, okay, so what we have here is we have various theta values. And down below, you might recognize this from the optimization tab that we talked about. So here we have x1 through x5. So we have 5 different input variables. And then you have, theta values that correspond to that, or model parameters. You might have a target value, so this would be y, an output, something that you've measured that goes along with those input variables. Y hat, again, what I did is I took and copied up above. You see these long formulas up above, and let's just go step by step. First, the x's. You defined a variable x and you selected all of these values within this box. You then defined a variable theta and you selected all the theta values. You see them in the upper left-hand corner there in the red box. You then defined a variable z. Z is, and we'll talk a little bit about this once we get into more of the machine learning course and videos, but z is like this intermediate state. Here we just have matrix multiplication of x comma theta, so similar to what we've done previously. We're then going to look at, name a variable y hat. So usually in mathematics, when you do y and you have this hat symbol over the top of it, that refers to an approximation of y. So here we called our target values y, and y hat is actually the prediction. Because the target values are between 0 and 1, we use what's called a sigmoid function, which, if you look here, it's 1 divided by 1 plus the exponential of negative z. Again, we've already defined z just prior to this, so that's going to be y hat. And the last thing here is we're going to talk about y. So y, you can see in purple there, it refers to our target value column. Our loss, this is where we get into kind of the difference between y and y hat. There's a specific loss function called a cross entropy loss function for this. Let's not get into that now, but here's the actual formula for that. And so I've used that formula and coded it up within this let function. The cost function, if you remember, that's going to be the average of all these loss functions, similar to what we did when we were using the mean squared error. And then last we have the output, and we're going to output y hat. So we're going to go back to earlier within this let function and output y hat. So let's go ahead and press enter, and there we go. And I can copy that again. And this difference, it's actually not difference squared, but this difference, let's go ahead and copy loss and put that as the last variable within this let function. So when we press enter, okay, that's very different. This is actually telling us how close our model prediction y hat is to our target. So this is what it comes out to be. So that's the losses. And now if we copy that again and put it down below, cost function, this is just, again, this is how we combine all the loss functions into a single value that optimization can operate on. So the lower this cost function right down here, then the better that the model is in predicting what the target values are. So that's how that would work, and then you could go ahead and when you're doing optimization, you want to minimize this average value, and you would want to do that by modifying these theta values up above. So that's how you would do optimization now. The interesting part about using this let function is these intermediate steps, which we showed in optimization. I can actually delete those. The function doesn't actually need those intermediate steps. All of those intermediate steps are actually contained, within this let function. So we've actually calculated all of these intermediate values within the let function, and we've only returned the final cost value which is necessary to do optimization. So it's really nice from that perspective as well, just because you don't need to show everything within the spreadsheet or make these long complex formulas within the spreadsheet. You can have these intermediate formulas and intermediate steps. And then if you wanted to check at any point, maybe for debugging if something goes wrong, you can always do what we did here and can show the values associated with things like y hat or the loss.